Welcome back. In this video, we're going to go over section 1.8 that deals with the real numbers. So we'll be taking a look at square roots and squares of numbers and the different number sets like natural numbers, whole numbers, rational numbers, and so forth, and look at ordering numbers on the number line, that is deciding which is greater and which is less. So let's take a look first at squaring numbers. So the first thing is we've got here, if n squared is equal to m, then m is the square of n. So try not to get too lost in the m's and n's there. We know that 4 squared is equal to 16. So that 16, I'm all dotting a 1. Okay. All right. 16 is the square of 4. Okay, so given a number, you can multiply it by itself and you get that number squared. -8 squared equals 64. 64 is the square of -8. 0 squared is equal to 0. 0 is the square of 0. Going the other direction, if n squared is equal to m, then n is a square root of m. So 5 squared is equal to 25, and -5 squared is equal to 25. 5 and -5 are square roots of 25. You'll notice a big difference between the square of a number and square roots of a number. You'll notice here we had a definite article, that is the for the square of n, but a square root of m. So when we're talking about the square root of a number, there is only one, right? So the is appropriate there. So when we say that, I used 8 already, 7 squared is 49. 49 is the square of 7. There's only one square of a particular number. However, because each number has 2 square roots, we'd say a square root. So 5 squared is 25, -5 squared is also 25. Both 5 and -5 are square roots of 25. So each number has 2 square roots. The one that is denoted by the square root symbol you've probably seen before is going to always be the non-negative one. So we would write the square root of 25 is equal to 5. This symbol stands for what's called the principal square root. And by that we mean the main square root, like principal is in the main one. Notice the spelling here is P-A-L, not P-L-E, principal, like your principles, like something you believe in. Principal here is P-A-L, meaning like the main one. It's the principal square root. It is always the positive one or non-negative. Okay, so as a couple of other examples, the square root, when I say the square root, now I'm talking about the principal square root. Using the square root symbol, square root of 121 is 11. Square root of 169 is going to be 13. If you ever want to refer to the other one, you would need to use a minus sign in front of the square root symbol. So minus the square root of 121 is how we would refer to -11. So there's square roots. We should have a couple of more. The square root of 0 is 0, since 0 squared is equal to 0. 0 has only one square root, actually. It's just equal to its own self. Square roots of fractions. The square root of 1/4 is equal to 1/2, since 1/2 times 1/2 is equal to 1/4. Okay, so that has been a little bit about square roots. The big thing to remember here is that for the square root symbol, that always denotes the positive one. You don't want to write things like the square root of 49 equals plus or minus 7. That's actually wrong. Okay, the square root symbol always denotes just the positive one. So don't be writing a plus or minus symbol there because it's incorrect. Okay. The next thing to look at is different number sets that we have to work with. The first one is the natural numbers, also called sometimes the counting numbers, because those are the ones that you learned to count on your fingers with when you were little. So 1, 2, 3, 4, 5, and so on. Those are the natural numbers. We also have the whole numbers, which are the natural numbers, but also with zero included. It can help you to remember the name by thinking about how the number zero looks like a little hole. And so that's whole numbers. Okay, so there's that. If you take the whole numbers and add on the opposites of the natural numbers, you get the integers. So basically the positive numbers and negative numbers together make up the integers. In other words, everything except for decimals and fractions and stuff like that. Okay, integers. Okay, we've already worked with integers quite a bit. Rational numbers look like P over Q, where P and Q are integers. So if you take a whole number or integer and divide it by another whole number or integer, as long as you're not attempting to divide by zero, then you get an integer. So in short, the rational numbers are basically the fractions. Okay. By the way, the word rational here is more like the word ratio. The first 5 letters make the word ratio. And that relationship to fractions is where the name comes from. When we say rational versus the next one, which is irrational, we don't mean like, if somebody's behaving irrationally, they're acting weird or crazy or something. It's not that. Okay, so this is more in terms of, can you express the number as a ratio or not? Okay, in terms of decimals, rational numbers either terminate or repeat. So the number 0.325 would be the decimal representation of 1/8, right? And that's a terminating decimal. If you had the number 0.65656565, and that's repeating, which we would note by putting a little bar over the 0.65, that is also a rational number because it repeats. A number that is terminates or repeats is a rational number. A number that is non-terminating and also non-repeating would be an irrational number. Examples are the square root of 6. The square root of 6 is not repeating. Most of the easy examples for us are going to involve square roots that are not perfect squares. In other words, where you're not able to find like the exact answer for, you could say. Like the square root of 36 is 6. Yeah, sure. But for this one, the square root of 6, is there something that you can think of where you would square it and get 6? And the answer there is no, just the square root of 6. As far as a decimal, though, if you tried to write out a decimal for it, it would be a non-terminating, non-repeating decimal. Okay, so those are the irrational numbers. So some examples now involving calculating square roots. So it says we're to simplify. So we want to find the numbers that square to equal the given numbers. So the square root of 36 is 6. The square root of 169 is 13. That one I just kind of memorized. There wasn't any way of working these out. Okay, you're just going to ultimately remember them. Here we have to be careful. There's a minus sign in front of this square root symbol, the square root of 100. So this will be minus 10. Notice that this is different from saying the square root of negative 100. The square root of negative 100 is not a real number. Okay, for square roots, you're only going to have numbers underneath the radical sign that are greater than or equal to 0 in this class. The deal with taking square roots of a negative is dealt with in a later course. For now, we'll just say it doesn't exist if you like, although it's technically not true. Or you can say it's not a real number. Okay, the square root of 4 is going to be 2, the square root of 9 is 3, the square root of 144 is 12, and then minus the square root of 1 is negative 1. Okay, one other thing that I wanted to mention is that frequently people forget to take off the square root sign when they write this. So I'll see on people's papers the square root of 144 is that, right? The square root of 12. This is actually wrong. once you've figured out that the square root of 144 is 12, you don't need to sit and write that square root sign on top anymore. Okay, that's already done. Just write 12. Okay. Okay, last setter for you. Take a second, pause the video, and then figure out these 4 square roots. And then we'll see how you did. All right, square root of 64 is 8. The square root of 16 is 4. Negative the square root of 4 is negative 2. And negative the square root of 121 is negative 11. Okay, and that's it for the square roots. Let me know if you have any questions on that. Okay, the next part is we're to decide, we're to write these numbers as the ratio of 2 integers. We don't need to do all of these. 5 first is the same as 5 over 1. It is a rational number. 3.19 over 1, that's not writing it as integers because 3.19 is not an integer. However, if we multiply the numerator and denominator by 100, we'll have 319 over 100, and that is a ratio of integers. Okay, and that will do it. Okay, let's do one more. Negative 12 is the same as negative 12 over 1. That feels a little like cheating, but any integer is also a rational number because you can always just put it on top of a 1. 9.279 over 1. Here I need to move the decimal point over 3 places to make the top a whole number, 9,279, and so that will make the denominator 1,000. Again, the point of doing all that is basically just to say, yeah, I know what a rational number is. It's when you write the quotient of 2 integers. Okay, in the next set of examples, we're to decide whether each number is real or not real. I'm going to use R for real here, and I'll write NR for guess what? Not real. All right. Okay, so negative the square root of 81 is going to be real. The square root of negative 121 is not real. The square root of negative 49 is not real. Negative the square root of 144 is real. In short, if you try to take the square root of a negative number, it's not going to be a real number. Another way of thinking about it for now is that if you have a square root sign outside of a root, that is okay. That will give you a real number. If you're trying to take the square root of a negative number, that is the minus sign is inside, that makes it so that it is not a real number. Okay? All right, so in the next part, it says in the following exercises, list the whole numbers, integers, rational numbers, irrational numbers, and real numbers. This question I don't especially like, sorry, because there's a lot of overlap in here. So that is every real number is, or every rational number is also real, right? So, but we'll do the best we can. Let's do 688, I guess. Okay, so how should we organize our information? All right, so whole, integers, rational, irrational, and then real is the last category. Okay, so let me start with the whole numbers first. So out of the whole numbers, the only one I see here is 0. Negative 6 is not, negative 5/2 is not. That's the only whole number. For integers, we'll have negative 6 and 0. And that's the only one. Rational numbers, negative 6, negative 5/2, 0. And then here, careful with the decimal. It says 0.714285, which looks like it has a lot of digits. But notice that there's a bar on the top, which indicates that it repeats. And as you recall, repeating decimals are rational. So 0.714285 with the bar on top. And then 2 1/5, and that's it. The square root of 14 is not. Okay, so no. irrational, only the square root of 14 is the only irrational one. And then out of real, instead of writing all down, we'll just say all of these. All of these are a real number. Okay, the only way that I would have a not real one here is to be having something with a square root of a negative in the list, and we have none like that. Okay, so that's fine. All right, so then the next part, we're organizing numbers on the number line. So this part is going to be to an extent about fractions. We'll do the best we can though. So we'll try 691. Okay, we're going to locate the numbers on the number line. So 3/4 is going to be in between 0 and 1. I know if we divide that up into fourths, right where the third of those fourths is, where would be where we'll find 3/4. Okay, and then 8/5, there we would be dividing the number between 0 and 1 into 5 parts, but we have 8 of them, so that will extend all the way to almost 2. 2 would be 10/5, so we'll just have to be a little bit less than that, put 8/5. Okay, I don't want to write all the tick marks this time because it's going to be confusing looking for you. 10/3, well, that's a little more than 9/3. 9/3 would be 3, and so 10/3 looks like it's around here someplace. 3 1/3, in other words. Okay, let's see if we can fit any more on here. Let's try 2/5 and -2/5. Okay, 2/5 is going to be a little bit under a half. And then -2/5 will be equally distant from 0, but on the negative side. Okay, so there's that. All right, so now less than and greater than. We're to order these numbers using less than or greater than sign. So remember that for a number that is smaller, the less than symbol applies. And when you do that, the numbers that are to the left on the number line are the smaller ones. And remember that both of those start with an L, if that helps you any. On the number line, the numbers that are less are on the left. And then greater than, numbers that are greater are on the right. Okay, so here it's a mix of some positive and negative numbers. So here, -1 versus -1/4. -1 is smaller than -1/4. -1 3/4 versus -2. -1 3/4 is larger. Okay, let's see what else can we do. -5/12 versus -7/12. -5/12 will be bigger. -4 versus -23/6. Here it might help you to turn the 4 into sixths. -4 would be -24/6. We're going to compare that to -23/6. -24/6, that's less than -23/6. Okay, so that takes us to the end of section 1.8 on real numbers. Actually, I lied. There's one more little bit. Sorry, I lied. Same problems, but this time decimals. Okay, 0.37 is less than 0.63. 0.5 is less than 0.3. 0.86 is bigger than 0.69. This one's nice, 713. 0.91 versus 0.901. If these were integers, I know that 91 would be less than 901, right? If you had 91 spiders in your bed, that wouldn't be as bad as having 901 spiders in your bed, right? So that's definitely true. But as decimals, you have to compare these according to place value. Both of these have 9/10, but the first number has 1/100th, whereas the second number has no hundredths, but instead a thousandth. So 91/100ths is bigger than 901 thousandths. Okay, and then let's see, one more decimal for the road. 718, -7.31 versus -7.3. -7.31 will be just a little bit less, 1/100th less. Okay, now that finally will do it for the end of this section. Let me know if you have any questions, and have a great